Across northern China, an enormous desert stretches for thousands of kilometers, where survival has always depended on scarce water.
For generations, powerful winds carried sand across northern China, threatening farmland, roads, villages, and entire communities. Then China began attempting something extraordinary, building a continuous green barrier against one of Earth's harshest landscapes. The ambition became known as the Three North Shelter Belt, stretching across China's vulnerable northern frontier. But planting millions of trees in such dry conditions created a brutal question: where would enough water come from? In many regions, rainfall is too low and unpredictable to support large forests without careful human intervention. So engineers had to think differently, choosing hardy plants capable of surviving heat, drought, wind, and poor soil. Instead of forcing tropical forests into the desert, China increasingly focused on plants naturally suited to harsh conditions. The goal was not simply to plant trees, but to create ecosystems capable of protecting themselves. That meant slowing the wind, stabilizing the soil, conserving moisture, and allowing natural vegetation to gradually return. The first challenge was stopping loose sand from moving before young vegetation could establish roots. Across exposed dunes, simple barriers were arranged in patterns that trapped sand and reduced wind speed. Once the ground became stable, carefully selected seedlings could survive long enough to develop stronger root systems. But even protected seedlings needed water, forcing engineers to develop precise methods for delivering every precious drop. Instead of flooding entire areas, irrigation could target individual plants, dramatically reducing wasted water beneath the desert sun. In some regions, treated wastewater and carefully managed groundwater became part of the restoration strategy. This turned the project into something larger than forestry, involving water management, agriculture, engineering, and environmental science.
Researchers also had to understand which species could survive without consuming more resources than the land could provide.
Every successful plant represented more than greenery. It represented another small piece of the desert becoming stable. And as those patches expanded, they began changing the landscape itself, slowing wind and holding moisture longer. Over decades, separate planting zones gradually connected, creating enormous belts of vegetation across northern China. These shelter belts were designed to break powerful winds before they could carry sand toward vulnerable farmland. At the edge of the Gobi, these shelter belts are the frontline defense, protecting the vibrant agriculture within from the desert's harsh winds. The barrier also helped create calmer microclimates, allowing moisture to remain near the ground for longer. Slowly, the trees stopped looking like isolated experiments and started becoming part of a functioning landscape. As vegetation matured, its roots began anchoring soil, creating stronger ground beneath the expanding green corridors. That stability reduced erosion, allowing grasses, shrubs, insects, and other small forms of life to return. The transformation was gradual, almost invisible at first, but increasingly obvious when viewed across decades. Satellite images began revealing something remarkable: green corridors spreading across landscapes once dominated almost entirely by barren terrain. What began as scattered planting efforts was becoming one of the largest ecological restoration projects ever attempted. But connecting thousands of kilometers of vegetation required planning on a scale far beyond ordinary forestry projects. Teams had to map terrain, study soil, monitor rainfall, and determine exactly where planting could succeed. The Gobi Desert presents unique challenges, yet these drought-resistant specimens thrive where others struggle. Altitude, temperature, soil chemistry, and available moisture could completely change the survival equation. So the green wall was never simply one giant forest planted in a straight line. Instead, it became a massive network of forests, shrublands, grasslands, and restored desert habitats working together. Each section had a different purpose, depending on the land, climate, water availability, and nearby communities. Some areas relied heavily on shrubs, while others supported taller trees once conditions became favorable. This flexibility helped engineers match restoration methods to the realities of an extremely diverse landscape. And this is where the project began looking less like construction and more like ecological engineering. Yet one enemy remained constant. The desert itself was always trying to reclaim the planted ground. Every severe dust storm tested whether years of planting could withstand a single violent season. Where roots were weak, plants disappeared. Where ecosystems were established, vegetation absorbed much of the storm's force. That difference revealed an important lesson. Survival mattered more than simply planting enormous numbers of trees. The project increasingly favored resilient ecosystems that could survive with less water and less constant human intervention. Some planting zones faced scorching summers, freezing winters, and dramatic temperature changes within the same year. Others battled salinity, shallow groundwater, rocky soil, or simply conditions too harsh for conventional forestry. This forced researchers to constantly adapt, testing species, planting densities, irrigation methods, and protection techniques. Failures were not necessarily setbacks. They showed which approaches could never work in specific environments. Over time, those lessons helped turn trial and error planting into a more precise science. As successful vegetation expanded, the surrounding landscape began responding in ways engineers had hoped to see. Wind speeds near mature shelter belts could fall, while drifting sand became easier to trap and stabilize. That meant less exposed soil, fewer moving dunes, and greater protection for communities living along the desert's edge. Farmers could benefit, as protected fields faced less sand intrusion and more stable growing conditions.
The green corridors were beginning to function not just as barriers, but as living infrastructure.
Once vegetation became established, wildlife also found new places to feed, hide, and move through the landscape. Plants created shade, insects returned, birds followed, and gradually more complex food webs began developing.
The restored zones also helped reconnect fragmented habitats that had previously been separated by expanding desert.
Here, in the heart of the restored Gobi, the delicate balance of the ecosystem thrives under the warm afternoon sun.
So the project's impact extended beyond trees, gradually reshaping relationships between soil, plants, animals, water, and people.
For people living near the Gobi, healthier land could mean greater security for homes, farms, and livelihoods. Farmers gained protection from drifting sand, while restored vegetation helped reduce pressure on already fragile surrounding ecosystems. But maintaining such enormous landscapes required people constantly monitoring trees, water systems, soil conditions, and seasonal changes. The Green Wall therefore became a long-term commitment, rather than a project that could simply be finished. Trees needed care through droughts, storms, disease, and changing environmental conditions year after year. And that raised another difficult question. Could such a massive system remain sustainable indefinitely? Water remained the most sensitive resource, especially as climate patterns continued shifting across northern China. Using too much groundwater could solve one problem while quietly creating another beneath the surface. That is why newer restoration strategies increasingly emphasized efficiency, native species, and natural regeneration wherever possible. Investments. Against the backdrop of the vast Gobi, this self-sustaining ecosystem is a testament to resilience.
Today, parts of northern China look dramatically different from the barren landscapes photographed decades earlier.
Satellite monitoring, field surveys, and decades of records now reveal how uneven that transformation actually is. Some regions show impressive recovery, while others remain difficult, dry, fragmented, and highly dependent on careful management. That unevenness is important, because turning a desert into forest is not actually the real objective. The deeper objective is creating landscapes that resist desertification while supporting people, biodiversity, agriculture, and natural processes. In other words, success is measured by stability, not by how green a satellite image appears. A healthy restoration zone should conserve resources, protect soil, and remain resilient through difficult seasons. It must also provide practical benefits without exhausting the water and ecological resources it depends upon. That balance is becoming increasingly important as northern China faces hotter temperatures and changing rainfall patterns. The next generation of the project will depend less on simply planting more trees and more on planting smarter. But the most astonishing part of the story is the sheer geographic scale of China's ambition. The broader 3 North program spans vast regions where desertification, drought, and erosion have challenged communities for generations. That means the Green Wall is better understood as a continental-scale network than one continuous forest. Different regions contribute different pieces, creating a patchwork of ecological defenses across northern China. Together, those separate efforts form a barrier against some of the forces driving desertification. Yet measuring success across such enormous territory is far more complicated than counting trees planted. Researchers must examine soil stability, vegetation survival, water use, biodiversity, and changes in local environmental conditions. Likewise, a dense tree plantation may look impressive while providing fewer ecological benefits than a diverse native habitat.
The strongest results come when restoration improves the entire system, rather than maximizing one visible metric.
Despite the progress, enormous sections of the Gobi remain naturally dry, barren, and difficult to restore. Some places are simply too dry, too cold, too saline, or too remote for intensive planting. Trying to force forests into every one of these environments could create new environmental problems. The Gobi ecosystem, though harsh, teems with subtle life. The challenge lies in balancing this natural beauty with the needs of a growing population. The Green Wall works best when humans cooperate with natural processes, instead of trying to overpower them.
Even so, the areas that have stabilized show how dramatically human intervention can influence desert landscapes.
Where restoration succeeds, bare soil can become habitat, farmland can become more secure, and communities can gain protection. But none of this happens quickly. Ecological restoration is measured in years, decades, and generations. A sapling planted today may take decades before its full ecological value becomes visible. That long timeline is precisely why the project is ultimately a test of patience, adaptation, and persistence. After decades of work, the vision is no longer just an ambitious idea on paper. Across northern China, real shelter belts, restored habitats, protected farms, and greener corridors now exist on the ground. The Gobi's shelter belt is not a continuous wall, but a series of vital ecological corridors.
It is slowing erosion, reducing sand movement, protecting productive land, and giving ecosystems more room to recover.
And perhaps that is the most important lesson. Deserts are not defeated by brute force alone. They are managed, studied, protected, and gradually transformed through thousands of small decisions repeated over generations. China's Green Wall is therefore less a single forest than a decades-long experiment in ecological resilience. The Gobi ecosystem is slowly returning. Through dedicated restoration efforts, life finds a way to thrive again. If that resilience continues, barren landscapes may gradually become safer, more stable, and more productive for future generations. The impossible Green Wall is still unfinished, but its legacy is already taking shape across northern China. What began as a fight against desertification has become one of humanity's largest experiments in living with nature.